If you've seen the HBO miniseries on Chernobyl, you might be wondering what a void coefficient is. So let me explain that. When it comes to controlling a reactor, we are able to lower the amount of fuel that's in a reactor by moderating the neutrons. And here's why. When fissioning occurs in a fissile nuclide, it's going to on average spit out 2 or 3 neutrons. They're really high energy. Those high energy neutrons don't have a really high probability of creating a fission in another nucleus unless we slow them down. And the best way to slow them down is like billiard balls. You take a neutron and you whack it into a proton where it will give off half of its energy. And you get a lot of protons in water. And so you cool a reactor with water, and it also acts as a moderator. In other words, it will provide the means to slow down those neutrons so you can increase the probability of fission for each neutron. Now, if you get too much water in there, it's going to actually act as a poison. And the reason why is once those neutrons slow down to thermal energies where they have just the same probability of being upscattered in energy as downscattered in energy just from thermal oscillations of the protons that they're in contact with, then those protons can actually absorb the neutron and become deuterium, an isotope of hydrogen. And so in that sense, water can be actually be a reactor poison. It will absorb neutrons and not allow them to be used in fission. And so if you have too little water in there, then the probability of fission isn't as high as it would have been if you'd had more. So there's an optimum amount of water to have in there. Too much, you're over-moderated, and you're acting like the neutrons are being poisoned by the water, and too little, and they're not being as thermal as they could be to increase the probability of fission. Now, Western designs always require that you have a negative void coefficient, meaning if you've got liquid water in there, it's just slightly under-moderated. So that if you put in a void, say for example boiling, when it's not supposed to be boiling, it's supposed to stay liquid water, then if you get boiling, then that means you've got basically a void. You've got a pocket of steam which acts more like a vacuum, and now you become even more unmoderated. So if you did get boiling when you're not supposed to have boiling, the reactivity goes down because you're already under-moderated, meaning that you just became even more under-moderated, and the reactivity goes down because the neutron economy is even less optimal. Now, if you're over-moderated, which is illegal in the West for our designs, then that means when you have boiling, when you're not supposed to have boiling, like what occurred at Chernobyl, reactivity actually goes up initially because you were over-moderated. The water was acting slightly as a poison, and it stops acting like as a poison, and now suddenly you're optimally moderated as you start to transition into boiling when you're only supposed to have liquid water. And so that's what a negative void coefficient is. It increases the probability that the reactor will shut itself down naturally, or it makes it more difficult for you to have problems. So